Chapter 4, Section 5 is about compound inequalities. So by the end of this lesson, you should be able to solve and graph inequalities containing the word and also solve and graph inequalities containing the word or. Now, a compound inequality is two inequalities put together. Sometimes they're connected with the word and, like it has to fit this category and this other category, or sometimes they have the connector or. They have to fit over here or they have to fit over there. So two inequalities that are joined by the word and or form a compound inequality. You can write the compound inequality x is greater than or equal to 5 and x is less than or equal to 7 as this. So they put x in the middle, and how we would read this is -5 is less than or equal to x, which is less than or equal to 7. So we have two things for here. And basically, if we graph both of them, the x is greater than -5 and x is less than 7, we see they overlap. And it's this purple thing that I'm highlighting with green right now. These are all of the solutions that fit both of those inequalities. And because our stipulation is that x has to be somewhere in between there, these are the only solutions. Another way to read this, down here this is important, is we can say x is between -5 and 7 inclusive. And that's just saying it's inside of those two numbers. So write a compound inequality that represents each situation and then graph our solution. So A says all real numbers greater than -2 but less than 9. So if we were to think about a number line, we'd have -2 here, 0 is not far away, and then 9 right here. And this says that we want numbers greater than -2, so not equal to -2, and less than 9. So we're going this way with the -2, we're going this way with the 9. So if we want to write a compound inequality, x is in the middle of these two things. We got -2 on this side, 9 on this side. And then we got to figure out what symbols to put in here. So we want x to be bigger than or equal to -2, but less than, sorry, not equal to, but less than 9. And for these, your alligators should always be pointing in the same direction. They're walking together. They shouldn't be turned on each other like eating each other, and they shouldn't be looking away from each other like this. So always facing in the same direction for these. So let's try B. B says the books were priced between $3.50 and $6. So again, if we think about a number line, we have $3.50 here, and $6 would be here. We have the prices in between these two, and because it says inclusive, we can include those two numbers, and we want this stuff here. So again, our books are somewhere in between $3.50 and $6. They can be equal this time, so we want it to be greater than $3.50, but less than $6. So now that we can write these, let's actually solve them. So solve each inequality and then graph the solution. Remember, the graphs just show us all of the solutions because there is still infinitely many of them. So when we look at this, we have -6 is less than or equal to 3x, which is less than 15. There's technically two inequalities hidden in this. So we can split this up into -6 is less than or equal to 3x, and 3x is less than 15. And then all we have to do is solve it, just like we would any other system. So divide by 3, divide by 3. We get -2 is less than or equal to x, and if we do the same thing on this one, we get x is less than 5. So now these two answers we can combine again and rewrite with x in the middle. We got -2 and 5. So there's our compound inequality. And then when we go to graph this, because the x is in between these two things, that tells us where all of our solutions are going to be. We can equal negative 2, so we can fill that circle in, but we can't equal 5, so leave that one open. And we want x to be in between, so any of those numbers inside of there work. So, you might ask, why split these things apart if we're just going to combine them again? You don't technically have to with the ands. The ors that we're going to do in a second will already be split up, but let's try this one without splitting it up. So, pretend this wasn't here for a second. If I asked you to solve for n, what would you do? Hopefully you said subtract 1, and you said subtract 1 from both sides. Now, we can kind of think of this as one more side. So subtract 1 over here too. So we end up with 6 is less than negative 3n, which is less than or equal to 12. So then, same thing, pretend this wasn't here for a second. What would you do next? Well, we'd divide both sides by negative 3. And remember, all this is just one more side to divide by negative 3. So if we do 6 divided by negative 3, we get negative 2. And be very, very careful here with these signs. We divided by a negative number. So that means we have to switch them around. This goes away and we just get n. Switch that sign again. Remember, make sure alligators are walking together, not eating each other or running away from each other. And then 12 divided by negative 3 gives me negative 4. So there's my inequality. And if we want to graph this, we have negative 4 down here, negative 2. Let's put 0 for reference up here. Remember, n is between these two things. So it can equal negative 4. Let's color that in. It can't equal negative 2, and we want all the numbers in between. So that was compound inequalities with the word and. Now if we switch to the word or, this is two separate situations that we're okay with our numbers fitting into. So if we read this first one, it says to write a compound inequality that represents each situation and then graph it. We want all real numbers that are less than negative 3 or greater than 7. So all real numbers, that's fancy for let's make it a letter. So we want all real numbers that are less than negative 3 or greater than 7. And this is our compound inequality. It doesn't get put together because it's two separate situations. And sometimes it's a little easier to see when we go to graph it. So let's do that. Negative 3 would be down here and 7 here. Now I want all the numbers less than negative 3. So they're going to be everything this way. And then all the numbers greater than 7. So they're going to be this way. So you can think if it says the word or, your graph is going to go out. Where and, it's everything in the middle. So discounted fares are available to children 12 and under, or to adults at least 60 years of age. So let's think about what that means. The discounted fares are for children 12 and under. So the fare is for children that are 12, so we can have the equal to, and under, so everybody less. Or adults that are at least 60 years of age. So remember, at least is the smallest number we're okay with. They can be exactly 60, but then they got to be bigger than that. So when we go to graph this, we have 0 way down here, 12, and then 60 is way the heck up here. We can equal 12 this time, so let's shade it in, and we're going to go this way. And then it can equal 60 this time, but it's going to go that way. And always double check that this makes sense. Children less than 12 would be like 1, 2, 3, 4, 5, up to 12. And anybody at least 60 would be like 60, 61, 62, 63. These people in between here, 12 to 60, don't get any discount. So let's solve one. These are a little easier because it's literally just two different problems that you put into one problem. So solve them totally separate. Your answers will be totally separate, and then you just got to put the word or in between. So if I start with this one, first thing I got to do is subtract 7 from both sides. So I get negative 2x is greater than negative 4. And then divide both sides by negative 2. And remember, because I divided by a negative, I got to flip my sign around. So here's one option. X is less than 2. Or I have this other equation over here. So if I add 4 to both sides, we get 3x is greater than or equal to 9. And if I divide both sides by 3, x can be greater than or equal to 3. So there's my two options. And when I go to graph this, hopefully they should go out. If they go in and meet in the middle somewhere, we did something wrong. So I want all the x's that are less than 2. So they can't equal 2. Let's leave it open. Everybody less is to the left. And then they can equal 3. So let's color that one in. And everything greater. And that's it. So can you solve and graph inequalities containing the word or? Make sure you solve it and graph it. And can you solve and graph inequalities containing the word and? Make sure you solve it and graph it. Write down any questions you have, and we can go over them in class tomorrow. Have a good night.